So welcome to this review course for AP Computer Science A. Okay, my name's Eric. I am currently teaching at Louis University. Okay, Louis University is located in where? In Illinois. So this university is where I'm teaching right now. It's somewhat a little bit like Santa Clara University. It's a Catholic university in the Illinois area. Okay, so that's where I'm teaching. I'm teaching robotics and also programming language over there. Okay, so today we'll get started for AP Computer Science review. Okay, that's where I'm working right now. I'm teaching part-time over there, and I also teach some other students for programming. Today we'll get started from first thing is exam taking strategy. Before that, first you must have one account in our website. So to go to the submission of your homework website, it is http, okay, and then moodle.eco24.com, okay. So you try to find this website, okay. Moodle is a tool, okay. Moodle. Moodle is just like Canvas, just like Blackboard, okay. It's one of the learning management system, okay. It's called Moodle. It's a little bit like Noodle. It said that it's M, not N, okay. Moodle, okay. That's the tool we are using. So Moodle is where you check Moodle. Okay. They have it is an open source course management software. So we use this. And then you come to the Moodle site. Okay, let me log out. Okay, let me log out my account. So when you actually come to the Moodle, okay, let me log out. Okay. So when you log in, you actually should see something like this, okay? And there's a up in the corner here has a login. You should click login, okay? And here you should put your username and password over there. So your username, we have a uniform way of having the username. So it's IB max, okay? So IB underline, okay? Your first name, for example, my name's Eric, so it's Eric CHOU. Okay, so basically your first name and the last name. Some of you are used the Chinese name, okay, because English names are like Amy. There are so many Amy. Okay, so I try to use Chinese as much as possible. So here you see that actually the username is like this. Okay, IB underline and your first name and last name. Okay, password right now is capital A, B, C, and then 1, 2, 3, $. Okay, everybody had the same initial password. So please log in and then change your password right away. Okay, please log in and change your password right away. So here you log in. So after you log in, you should see something like this. Okay. So you see something like there are some listing of courses. And the one you have, it should be this one, the orange color one, CS24 review course. Okay, you should see this one. This one is our AP ComSci review course. So click over here. Okay, click, you will get in, and all the teaching material and exam submission will go through here. Okay, so let's click this one overview for the AP Computer Science. Okay, here's some material. Okay, and you can click week 1. Week 1 is currently the current week. Okay, so you can click week 1 exam taking skill. Okay, So that's the slice I'm using right now. Okay, so you need to take some note, but not too much. Okay, but not too much. So here, this one, you can always download the slides from here. Okay, and we merge the week 1 and week 2 together because we have limited time. So you may see that week 1 and week 2 actually is in the same week. Okay, it's okay. We will merge them together, and I'm going to cover both of them today. Okay, so you know, week 1 is just simple exam taking strategy. So these are the exam, and then next one is actually, you will see that there is a parents practice quiz. Okay, this one is from parents book. Okay, so we teach you the week 2. And after that, you should review the material in week 2 and then take the quiz over here. And the quiz are only in multiple choice, okay? And you don't need to return this one. I already give you the answer key, just like you get the answer key from the parents book. So you can just check by yourself, okay? And then what you need to return is the assignments, okay? So assignment here, you do see McGraw-Hill exam 1 and AP FRQ 2011. Okay, so here these are 2 tests you need to submit. Okay, so this McGraw-Hill exam is a full set. Okay, sorry. So by full set, we actually means that it actually is 40 multiple choice and 4 FRQ. Okay. And then under it, you can see this one, 2011 FRQ. This one actually is 4 FRQ, okay, 4 FRQ. But 2011, there's a Great War problem. There's a Great War problem that discontinued in 2016. So if you see that one, you don't work on that one. So basically, this one dropped to 3, only 3 problems you need to work on, okay? Only 3 problems you need to work on. So if you see some Great War problem, don't work on it. Okay, there's no need to work on it. The exam, the problem already been taken out from the exam, so we no longer test that. So basically, right here, you should have roughly 40 multiple choice and 8 FRQ to work on every week. Okay, so how to do it? I would suggest you to work on 10 multiple choice and then 2 FRQ a day. Okay, that roughly will take you 1 hour to do it. Okay, so 4 days a week, you find 4 days to work on it. Okay, otherwise you may not be able to finish that. And more problem is good for you because your score usually will go in this way. Okay, so for student get started, usually is somewhere like 43, 33, 55. That's actually normal. Okay. Full score is 80. Okay, you need 61 to 65 to pass 5 level. Okay, you need about 48 to 50 to pass 4 level. Okay, we use 80%. Okay, so 80% of the 80 point, it is 64 point. We use that usually when we do grading. We use 80% as a point to decide whether you are 4 or 5, and we use 60% to decide whether you are that's a 48 point to decide you are 3 or 4. Okay, 48 you make 4, 47 you are 3. So here if you 40%, that actually is 32 to decide 2 or 1. Okay, 3 or 2. Okay, 3 or 2. So that's about that. Okay. And it takes some practice to move up. Okay, my experience is there are some students after some practice. Okay, they started from 55 usually, 55, 58. Usually the first time, very rare, very few people can make 60 something. Okay, but they usually go up, and roughly around week 5, we will see some students passing 61. Okay, so in the 5 range. Okay, and week 7 or week 10, we do start to see some student passing 70. Okay, and usually the student, there are some student that is like a black line. There are some student never improve. Okay. That depends on how much you practice. Okay, that depends on how much you practice. So practicing is very important. We teach you the fundamental idea and also you the idea. Okay. Yeah, the username is underline. Okay, it's underline, not dash. Okay, let me know if you still have questions. You can voice out. Okay, if you have question, you can raise your voice. Let me know. Okay. Okay, so that's about it. So now let's look at the exam format and exam taking strategy. Okay, so that's the week 1 material. Week 1 exam strategy. So multiple choice section. Okay, there are 40 problems and the breakdown is like this. Okay, they break down into 10 units. So there are 40 problems. So 2.5% means 1 problem. Okay, so primitive data type, it means that 1 problem to 2 problems. So very few of the primitive data type. And then object is 2 problems or 3 problems. Okay, 2 questions or 3 questions. So you can look at this one to know that which part is more important. I would say usually array, 2D array, and array list more important. Okay, iteration for loop very important. If then else, this portion more important. Okay, this few one actually are more important. The middle one are more important. Okay, so these are the breakdown for the waiting for each problem. Okay, they are you are allowed to work on it for 40 questions for 1.5 hours, 90 minutes. Okay, here there's some trick. Okay, so in the past you are working on the exam using the paper format. So paper format, you will be given a booklet. Okay, a booklet, and then you will have an answer sheet. So for those of you who took the exam before, you should know that you do bubble. Okay, you do bubble. That's the paper exam. So the good thing about paper exam is that, okay, you finish the Q1, you move on to Q2, you will be able to go back to review Q1. Okay, so you can bubble them and then come back. Okay, later. That's a paper exam. So if your school allows you to take paper exam, you take this one. Okay, and it is also possible this year may still have a digital exam. Okay, so digital format, it is more challenging. Okay, you will be given a certain window, a software. You need to install some software from College Board, and then using the software, you will bring up the question 1. Okay, this format is 2021. Okay, 2020 they have different version. 2020 no longer use that format. 2020 is only experimental. So 2021, use 2021 as an example. If a question 1, so there are some question description and you pick A, B, C, D, E, okay, whatever you say, you pick A. So you finish the Q1, you click submit, and you move on to Q2, okay? And then continue Q3, Q4, Q5, Q7, Q15. Okay, now in Q15, you actually figure out, hey, my Q3 may be wrong. Can you go back to Q3? No, you cannot go back to Q3. Once you finish Q2, you cannot even go back to Q1. Okay, so digital format is more limited, more challenging. Okay, so the exam taking skill or strategy in paper exam and digital exam would be different. Okay, so you are given 90 minutes even. Okay, everybody the same 90 minutes. Okay, paper exam, I'll suggest you that each problem you are allowed to be 2.25 minutes, roughly 2 minutes. Okay, so if you have 40 questions, 2 minutes it actually is 80 minutes. So you may have 10 minutes to go back to bubble or actually correct some error. Okay, to check. So that's a strategy you should use, 80 and 10. Okay, so try to finish the problem in 2 minutes. There's no penalty. So there's no guessing penalty. So you should, if you don't know and you struggle for 5 minutes, I would say you just bubble something there. Okay, guess, no penalty. So you just bubble and move on. okay, bubble and move on. So that is the paper format, okay. In this digital format, that's actually total different, okay, totally different because you cannot go back, okay, you cannot go back. So now the question is, time management is more important in digital format. Why? Okay, let's assume that actually the first problem 1 to problem 30, you use 30 minutes to finish that, okay, and you have 10 more problems, and you still have 60 minutes. So what? You actually kind of save too much time for the last 10 problems. And if you rush the first 30 problems, you kind of lose. Okay, this one is no good. I mean, this one is no good. And there's another problem that, okay, some student actually, the first 10 problem, he used like 15 minutes. Okay, and the last actually 30 problem, he only had 40 minutes to work on. That kind of time management is also no good. But because that you cannot go back, then that is very challenging. So if you really find out that you're get stuck on certain problem for 5+ minutes, I would say just guess and move on, okay? Because you cannot afford that you kill too much time and then the last 10 problem, that's a 30 problem, you only have 40 minutes left. That's too few, okay? So better breakdown would be something like this, okay? You have 40 questions, so 10, 20, 30, 40, okay? And this, I would suggest that you use like 15, 15, or 15, 20, 20, 25, this kind of format, okay? So this would be better. The first few problems usually easier, okay? And then you start to actually put more time on here. But do not actually finish the first 30 problem in half an hour. And then last 10 problem, you actually have 1 hour to work on it. Then what? Then actually, well, your first 30 may be rushed. So do it with care, okay? With care, but actually budget your time wisely. This digital format is more tricky. Once you hit the return, no go back, okay? No go back. Now, let's look at the FRQ. FRQ, the same thing, okay? FRQ, you will be given a booklet and you need to write on the paper, okay? You write on the paper, so if you are in the paper format, okay, you are given enough area to answer the question, so you write something over there, okay? And then please leave some space for between the different lines, okay? So in case that you need to insert something, you don't need to erase the whole problem to write. So in paper test, you try to save some space for it, okay? And for us, I would require you, if you take the paper exam in your school, I would require you right now to use a 3-hole paper, 3-hole college rule or white rule paper, okay? Write your answer on it, okay? After that, you use your iPhone. You use your iPhone, take a picture on it, send the JPG file to me, that actually is okay. Okay, because I want to see your writing. Our grader want to see your writing. Okay, our grader want to see your writing. We don't need you to type. If you are taking paper exam, okay, so that would be something like this. Let me show you. Some student did that before. Okay, so let's actually look at the student who actually submit the exam before. So some students submit a FRQ before, so she will return something like this. Okay, one problem she actually writing like this. Okay, so then I put my my scoring on the right. Okay, so she's doing well because her writing is very good. Okay, very uniform. Okay, so don't do cursive. Okay, when you type, do not do this one. Okay, don't write it like this. Okay, 4. Okay, integer. Okay, I equals 10. Okay, whatever. This cursive, don't do cursive. Okay, try to actually print it. Okay, try to print it. So 4. Okay, int. Okay, I equals 0. Okay, and also avoid O. Okay, don't try to use O equals 3. Okay, O actually look like 0, so do not write. Try not to use the variable O. Try not to use the variable z. Z sometimes look like 2. Okay. Try not to use the variable L. L look like 1. Okay. So these are some paper testing. You try not to use those kind of variable. If you need to use a L, I would suggest you to write LL or ALL, something like that. Okay. Try not to use a single L. Okay. But look like a 1. Same thing Z, if you want to use a 0, you just write 0 like this. Okay. Don't write a Z. That look like a 2. Okay. The reader may get confused. Okay. Any questions so far? Any questions so far? No question? Okay, so this actually is FRQ. If you do paper exam, please just take the picture, okay? And usually the whole set, you may send me 4 or 5, okay? If your part solution is okay, I click say okay, no deduction. And overall problem, I give you some score. So usually one problem, we give you maximum of 9 points. So 9 points based on deduction, you get maybe 9 out of 9, maybe 7 out of 9, okay? There's a reader point. Reader point, I give you 1 point or no point, okay? So based on what? Based on whether if I read your problem, I believe that you know what you are doing, then I'll give you the reader point, okay? Something like this. So usually it's like, okay, you may write something like this for I equals 0, okay? I less than 10, I increase, okay? And then I believe that you know it, okay? For some reason, you do it. But here you forget to put int, okay? And somehow you have grammatical error somewhere, many places. So it may -3, but I look at your solution and I determine, hey, this guy actually know it. So I give the extra reader point, okay? If I believe that you really know it. If I find out that, okay, this guy really actually just put something garbage there, trying to write something, I may not give you 0, but I may give you 1 or 2, but I won't give you the reader point. So the reader point will not be given, okay, in that case. Is that okay? If you do write something that I don't know, I don't understand what it is, then I won't give you that, okay? And that reader point is used for that purpose. It actually decided by the reader's choice. Reader decided that, okay, this guy understood it and he may make some mistake somewhere because of grammatical error, but that is minor issue, then we will give you point, okay? But if you really don't understand it and you write some garbage on it, we may not give you 0 point because of your labor work, okay? We may give you some point to avoid you trying, okay? But usually may not give you the reader point. So the strategy is you have 4 FRQ, maybe 2 are easy, so you need to get, okay, 4 FRQ, 40 point, okay? You may get, so that you have 4 FRQ, okay, 40 point. You have 40 multiple choice, okay? So it suggests that your multiple choice, you should get 60, I'm sorry, you should get 35 here. You get 35 here, okay? And then your FRQ gets 30, okay? So in combine these two, you will get 65. So greater than 64 is 5 label, okay? 65 will be very secure to get a 5. In a history, no breakdown higher than 65. 65 is the highest mark to use to the separator to be the breakdown for 5 and 4. Okay, never be higher than 65. So let's pick that as our goal. Okay, so you try to score 35 and 30. So this one 30 equals 7 plus 7 plus 7 plus 7. That give you 28. Okay, that's not enough. You are short of 2 points. So you need to have 7, 7, 8, 8. Okay, AA means that you have the reader point for 1, reader point for 1, reader point for 1, reader point. So you can only deduct for 1 point, 1 point, 2 point, 2 point. On the average, you deduct 1.5 point, per question to get 30. And 35 is hard for multiple choice, okay? 35 is not easy to get for multiple choice. So if you don't get 30 on your FRQ, your multiple choice, why? If you get 25 on your FRQ, this means that you need to have full score of 40 to be able to get a 5, okay? So FRQ drop too low, you are in big trouble, okay? You are in big trouble. So FRQ is very important. If you can actually score 40 on your FRQ, you score 40 on your FRQ, this portion you just need 30. I'm sorry, actually, you just need 25, right? So FRQ is very important. FRQ determine how much you need for your multiple choice, okay? So 7788 is the minimum you need to try to get. That will give you 30 points, okay? That will give you 30 points. Now, but usually not 4 problems are the same. So you don't get a 7788, okay? The suggested breakdown for 4 problems would be the easy 2, you should get 10-10. Try not to have any error. And then the medium one, you get 7. And then the really tough one, you try to write something, but you need to get 3. So this you get 30. Okay. So getting the easy one perfectly is very important. Is that okay? If you are easy one, you get 8, you are in big trouble because your tough one, you don't have margin of error. Okay, you cannot allow too much error in the tough questions. Any questions so far? Hello, any questions so far? Let me see. Amy Zhao. Okay, Amy, do you have any question?
No, I'm good.
Yeah, okay. Does that make sense so far?
Yeah.
Okay, good. So this one is the strategy that you should pick for FRQ. Okay, multiple choice. Usually you get started. When I look at the score, the student get started usually is 25, 23, 28. Okay, so it takes quite a few practice to get to 35. That's the goal we have. Okay, and usually people struggle at 31, 32 range, up and down in that range. Okay, because they may not be well prepared, so they struggle over there. If you struggle over there, cannot break through to 35, you are in big trouble. Because why? Because you need to have quite high FRQ to compensate for it. Okay, and that really you need to work hard to get 35. Okay, 35 is almost 90%. Okay, out of 40, 36 is 90%. Okay. So not easy, actually not easy. You almost need to score 90 plus to get 40, okay? So that portion need to pay more attention to it. But if you send me some solution, okay, the first week, you give me some solution, okay, and I graded, our grader graded and figure out you are 39 plus 40, and you are 79, okay? I would say almost impossible, okay? Unless like you are genius. Okay, even myself, I don't get that high on the first test. So that can only mean something that you actually copy from the answer sheet, okay? So don't do that, okay? Please don't do that. You will lose your opportunity to practice. Okay, don't do that. Please don't do that, okay? So that actually, if I do see some problem that is, I'll tell grader to not get actually try to test the student one more time. It doesn't make sense that a student gets 79 on the first ever practice. Okay, if that, then he doesn't need to take this course, right? He just go to take the exam directly. Okay, and usually that's not that easy. Okay, I do see students going to Harvard, going to Stanford. They all get started from 58. Pretty high already, 61 maybe. The highest one I see some student do the first practice is 63. Okay, so you give me 79 on the first exam, I would say impossible. Okay, I do see some students go to MIT, go to Berkeley, okay, go to Harvard, go to different school. I don't see that some number like that on the first exam, okay. I don't see that. You make mistake, careless mistake sometimes, okay. Even myself, I don't score that high whenever I take the first exam, okay. So that's the strategy. And FRQ, okay, FRQ in digital format, okay, you are allowed to use the College Board software alone, okay. So do not use your Dr. Java to test your program. No, it's not allowed. Do not use your Visual Studio Code to test it. Do not use your Eclipse to try it. Do not use your BlueJ, okay? No editor is allowed during the exam. You should only use the College Board editor, and you can only type English, okay? It's not allowed that you use a BlueJ and then copy to the solution area. No, not allowed since 2021, okay? 2020, yes, 2020 and that year is a COVID-19 year, and they allow students to do copy, okay? And some people cannot upload, so they decided not to do it. So you can only type the answer to the editing area, okay? And again, this digital format, there's no turn back policy. So no turn back policy means that you cannot go back to change your answer. So same thing here for FRQ. You finish your Q1, okay, in 3 minutes, good, congratulations, you are smart. Hit return. You go to Q2, actually you actually finish 5 minutes and return. Okay, sorry, you go on to Q3. And if you at that moment decided, hey, sorry, my Q1, I should forget to declare something. Sorry, too late. It's gone. It has nothing to do with you anymore. You can never turn back in digital format. No, okay, no way you can go back. So there's no need that you rush it in 3 minutes and hit return right away. Please check carefully, okay? So here, actually, this strategy is that no matter how smart you are, okay, try not to make such a stupid mistake for submitting too early, okay? If you are taking digital format. This year, I don't know, because the COVID situation is still very blurred. I really don't know whether you will get a digital exam or not. So my suggestion is that 1 week you submit paper, taking the paper exam, 3 whole papers, submit the JPEG file to us. 1 week you try to use a editor, your notepad. Don't use something that give you some hint, okay? Use your notepad, simple editor, and submit a file, or use our online editor to submit a file, okay? And that would be safer. That will give you the real practice, okay? That will give you the real practice. And then budget your time wisely in FRQ, okay? You have 90 minutes to work on. You have 4 FRQ, okay? So do not try Q1 10 minutes, Q2 10 minutes, Q3 10 minutes, and Q4 you will have 60 minutes, okay? Too much for Q4, okay? But if you actually do this, Q1 you do 30 minutes, Q2 30 minutes, Q3 20 minutes. Sorry, this guy only had 10 minutes. You may actually also, this may not be good as well. So totally you have 90 minutes for FRQ. Each one of them is average 22.5 minutes. Okay, so it's roughly 20 minutes. So a better breakdown, I would say, still be 15, 20, 20, 25. Okay, something like that. Okay, still be, well, the last one you may want to save for 30 minutes. That actually is okay. So I suggest that some easy one you budget for 15 minutes, and then 20, if you can solve it in 20 is good enough, okay? So by this, you already use a 55, you still have 35 to use for the last one, okay? Is that okay? Hello, is that okay? But because there's no turn back policy, so once you hit submit your digital problem will be gone. You can no longer go back to Q1 in your life. No way you can go back. So forget it. No matter good or bad, that's done deal already. Okay, don't turn back. You have no way to turn back in digital format. So if you are allowed to choose a paper test and digital test, okay, if you are allowed the option to choose it, I personally recommend still doing better. Paper is better than digital. Okay, digital format just give you more headache. Okay, submission value, internet connection breakdown, and also no turn back. Okay, this actually just add more trouble. Any question? So here, William, do you have question?
No.
No. Okay, that's actually the strategy. Okay, we discussed this strategy. Just make sure that you know about it. So pencil, you need to prepare pencil, eraser. No calculator. Calculator is not allowed. Okay, calculator is not allowed. So this is about it. Okay. So I pretty much cover this week one. I do not go over each one of them. Okay, here the question type. The FRQ question one is always program structure. Okay, FRQ problem one is always program structure. So you will be required to take an exam, writing a function, writing a if for loop. So usually this one will take you to work on for loop or while loop, okay, or modular or mesh or if then else. Okay, this problem one is on the program structure. Okay, on the program structure. Problem two actually is on class design. So you must remember how to design a class. What are the requirements to write a class? Okay. Problem three is 1D data structure. So array or array list. Okay. Problem four is 2D array manipulation. So these four questions since 2020, they fixed the problem type. Okay. Before that, they can test whatever they want to test you. But recently, they decided to just narrow down the scope, make it easier for students. So recent score do have a hike. Some more fight right now, okay, more fight than before. But here, actually, these are the four problems type, okay? Any question? Hello, any question for the problem type? No, no question. I'm going to move on, okay? No question. I'm doing that. So this exam taking skill strategy big one is about that. Okay, let me actually because we are not we have limited time, so I need to budget our time as well. Okay, we still need to go to week 2 today. So here in the overview, you do have the AP subset. Okay, so these are the subset that they will test you. Okay, so for the string, you need to know about string constructor, a string length, substring, 1 parameter and 2 parameters function. You need to know it. Okay, and then index of function. You need to know about index of function, equals function, compare to function. These are these actually are from College Board. Okay, 2019 College Board copy. Okay, so you do need to follow it. Okay, these are the function. Whatever show up in here, it is okay that they test you, and it may show up in the FRQ section as well. Okay, so this different function you need to have it. Integer the mean value, integer the max value. Okay, constructor for integer, in value. Okay, double value. Okay, ABS function, power function, square root function. These are required. Random function, these are required. Size, adding, add, remove, get, and set. These are already class. You need to know about these different functions. Object class, you need to know about equals and toString. Is that okay so far? This is a so-called AP subset. They will test you. Okay. So remember to download this one and take a look on it. This one is AP subset. And exception, what kind of exception that you need to know? Okay. Here are 5 exceptions you need to know. Okay. Arithmetic exception, null pointer exception, index out of bound exception, array index out of bound exception, illegal argument exception. So these 5 type of exception, they may test you which kind of exception it is. You need to know which type it is. Okay. So exception, there's a listing of required runtime exception. Is okay? Any question on this one? Let's see. Lin Pen. Okay. Lin, do you know? Do you have a question?
No.
No? Okay. Just make sure, okay? From time to time, I check with student, make sure you are okay. So that is that. Okay. Next one, answering guideline. Okay. This is something you actually can download. I already covered the answering guideline. So this one, you just download to read it, okay, later. Okay. And scoring guideline. Okay. Scoring guideline is how actually they will score it. Okay. How they actually score it. Number one, general penalty, they will deduct it for you. Okay. Use local variable before you declare it. Okay, this one you will deduct 1 point. So say you just write a equals 3, and before that you do not write integer a equal integer a. You do not declare it, but you use it. Sorry, this one is local variable without first declaring it. You will be deducted for 1 point. Okay, return the value from the void method or constructor. Okay, so you declare the function as void, but you do return 3. This one you deduct 1 point. But if you have a void function and you terminate the program with return, that actually is legal. Okay, that actually is legal. So here, this one, be careful. Okay, and then you have the array list. You have an array list, but actually you do this. You do a of 1. If A actually is array list, you deduct for 1 point. If you have an array, but you do use a get 1, same thing, you are in trouble. You actually will be deducted for 1 point. Okay. Overwriting information passed as a parameter. Okay. Over information passed by a parameter. So this one is a stupid mistake, such as you do this integer A, okay, and you have f function and integer b, okay, and inside here you declare integer a. Sorry, this one deduct for 1 point. Okay, it's okay. Don't redefine it. You are going to be in trouble. Okay, and here maybe okay. Here maybe you actually write some unnecessary code. Unnecessary code means that okay, you write integer I equals 0. Okay. Whatever. Inside here, you write integer j equals 3, but you never use it. It's a redundant code, it's a garbage code. This one, no deduction. But if you forget to put the integer, that you actually is an unnecessary code and has a side effect, then you are going to be deducted for 1 point. So we would depend on whether it's actually necessary code or unnecessary code, and actually see if it will cause the compiler to fail or some wrong output. That'll give you the penalty. And below are no penalty, but I do not suggest you to do it. Okay. For example, you actually come up with some code like if a greater equals 3. Okay, you do not write in the Java format. You write in mathematical format. Sorry, this one no deduction. But when you do practice exam, we will deduct it 1 point for you, because this one you should not write it in that way. Okay, because you write it in that way, maybe the reader point you will lose it. The teacher may decide this guy actually don't know about Java. Okay, so that actually will be deducted. And sometimes if you do if actually A equals B, no deduction, but I will still deduct your point in the practice exam, because this one actually is legal, and also you will create side effect. You will multiply the result of A. Okay, it actually is legal statement. So do not do this one. Okay, do not do this one. Okay. you will be in trouble. Okay. So there are some other rules you can look at it. Okay. Some other rules you can look at it. But these are the penalty, how they decided the penalty. And every reader, because it's human reading your problem, your answer, okay? So they may make mistake. They may make mistake, even though there's a guideline. So don't insist to write something wrong, okay? Don't insist to write something wrong. Don't actually think about, hey, you say that there's no deduction, so I would just write it in that way. No, if it is wrong, just try not to use it, because a reader is human. They may forget about this rule and give you deduction, okay? It's a human eyes inspection, so we cannot guarantee that they don't make mistake or they always remember the guideline. We cannot guarantee that. Can you do review on your FRQ? Yes. If you have one reader give you 3 points, the other one give you 8 points, the difference is too big. They will ask the third reader to come in to check. Only when that. If you are actually 7 and 8, sorry, they will pick one of them, maybe higher one, maybe lower one for you, but they won't ask for review again. Okay, they won't. Okay, so this one very important. Okay, very important. Okay, so that portion is our week 1. Okay, any questions so far? Any questions so far? Okay, if no question, I would like to go to week 2 earlier, because I don't want to waste time on this exam taking strategy for too long. So we will start this week 2 material right now. Okay, so get started for this review portion, because some students may need more help over here. Okay, so get started for here. So remember that each week you finish your reading, work on the quiz. Okay, this one no need to return the quiz. Okay, there's an answer key already given. You check by yourself. Okay, make sure you understand it. The assignment you need that. Okay, so week 2 we have assignment. Week 3 we have assignment. Every week we have assignment. Okay, please return them. We are graded for you. Okay, so when you submit the solution, so let's see. Say this is exam 2. Okay, so let me change my role to student. Okay, so here I can actually put comment. Okay, you can put comment, you can actually add submission. So let me add submission. So add submission, I can type my FRQ over here, right? I can type my multiple choice over here. Okay, so for the multiple choice answer, I would do this. Okay, please do this. Okay, please do A, B, C, D, E. Okay, A, B, C, D, E. So 10 problem a line, and then A, B, C, D, E for the 11 to 20. Okay, A, B, C, D, E. So something like this. Okay, we will have auto grader for you. So 40 problem, please put it this way. Okay, put it this way. Okay, I prefer this way. Okay, do not give us this. Okay, don't give us this. Question 1A. Okay, question 2B. Okay, so this one actually is harder for us to grade. We have auto grader. Okay, we have auto grade. So give me A, B, C, D. Okay, whatever. Okay, five problem. So let me show you how I grade it. Okay, let me show you how I grade it. So here, let's assume that actually I go to some previous exam. Okay, let me show you some student already took some exam before. Okay, so let me show you this. Okay, right here. Okay, so let's assume that let's actually have this student called Lillian. Okay, she has some solution and she typed in one line. I suggest that to have 5 answer and then separate by space, 5 answer by separate space, but somehow she doesn't follow my rule. But it's okay. It's okay. Let's use the one she has. Okay. So she give me this. But it's harder for us to read. Okay, harder for us to read. Okay, so she submits something like this. So I actually would use the window R. Okay, bring up the commander. Okay, and do CD. Okay, change to this directory. Okay. And then right here, I actually use a Python and then greater the py. Okay. So this one will be this student called MGH. Okay. Lilian. Okay. U2. Okay. So it is suggested that you try this. Okay. Try book name. So book name may grow here. We know this may grow here. Okay. Second, you actually type in your first name or last name. So Lilian. Okay. And then Unit 2 problem, okay, something like this, okay. So 2011, something like this. We should see your text file, okay. And using that, we hit return, and I would use the answer key, okay. So here key U2 answer key, okay. So here, okay. And I got a report, okay. And I got a report. So I got a report by doing this. I have an auto grading machine, and I got a report. Okay, the answer key is like this. Student's answer is like this. Okay, error problem 3 is error. Problem 3 should be D. Okay, should be D. This one is the desired answer. Okay, problem 3 she is wrong, and then out of the 16 problem, 1 wrong. Her correctness is 93%, and suggested score 5. Okay, my program will automatically do it. So basically, please submit a file that would be better. Okay, trying to separate. So if here you leave quite many space, but doing this, okay, my program will actually be able to read it. Okay, but do not do this. Okay, do not do this A dash B dash. Okay, and whatever mark, that H1 mark is not allowed. Don't do this. Don't do problem 1. Okay. A, okay. Don't do this. Don't say Q1, question 1A. Okay, that can only make my reader not able to process it. Okay. Any question? And FRQ, you actually take the JPEG. Oh, okay. So multiple choice, you can also submit from here. Okay. You can use a text file. Okay, and you can take the picture. Okay. And I will, and then upload the file, okay, whatever file you want to upload. For example, that me use the same answer from the student, okay. From a student, she has a JPEG file that's actually upload a JPEG file. Okay, take the picture and upload it. And I should see something like this, okay. So say you finish this one, you save change, okay. So at this moment, it turned to the drop mode, okay. It turned to the drop mode. Right, it actually is. Okay, it actually is safe. Okay, so let me go back to here. Okay, go back to the problem. Okay, so here let's look at this exam 2. So right here, it already is a drop mode. At this moment, it's drop mode. Okay, drop mode means like, okay, you have not finished yet. You have not finished yet, so you can go back to edit. Okay, go back to edit. So go back to edit. You may decide, hey, this program is not what I want. So let me actually choose delete. Okay, delete, then that is gone. Okay, and then you can reload one other file. Okay, so if you not done yet, keep it in the draft mode. Okay, keep it in the draft mode. And once you are done, okay, once you're done, hit this submit. Then the exam will turn to grading mode. Okay, so you ask you, do you want to continue? Yes, continue. Okay. Then you will become a firm case. Okay. Then we will grade it on it. Okay, we will grade it on it. Okay. So this one we are done. Let me go back. Okay. Oh, it's not done yet. Okay. So please, this is for submission. Okay, it may take longer. That's just don't wait for it. So that's the way you submit your homework. Okay. I explained the multiple choice and FAQ. So let's go get started for week 2. Okay, week 2. So week 2 is basic programming. Okay, basic programming, and we will test you on the basic loop. Okay, and concept of the programming. So first is package and class. Okay, package and class. So typically, Java program has user-defined classes. Okay, and there are some packages. So you may need to use a Java.language or Java.util. Okay, this portion, let me use a program to explain it. Okay, so here, let's get started. Let me bring up the project. Okay. So any questions so far? How about Natasha? Do you have question?
No, I don't have any questions.
Okay, so here let me create a new project. Okay. If you have any question, you can always voice out. Okay. So right here, I'm going to create a directory called project. Okay. Project is a tool I use to teach Java. Okay. So here I'm going to type week 1. Okay. So week 1, you create a class. So here let's do a data class. Okay, data class. Okay, so this data class is a class. Okay, it's a class. So it's a basic program unit is a class. Okay, the basic program unit is a class. So right here you may actually import. Okay, java.util.scanner. Okay, so java.util is a package. Okay, package means that someone had already write it for you. So that's a package. Okay, and then you have a class, and you actually may write a public static, okay, void main, okay. So that actually is a program that you need to have a main program. The main program was started from here, okay. So right here you have, you can have, so you may need to use a scanner. Scanner is a class, okay, you assign input and then new scanner. Okay. System. So this one hook up the keyboard with your program. Okay. Then you do integer a equals input next. Okay. So you read in the integer. Okay. So right here you may need to prompt to the outside. Okay, and you do system.out.print. You print out the variable a. Okay, that's it. So this one's a simple program you get started. So there's a class. Class is the smallest unit of a program. Okay, so enter 10 and you print out it. So this scanner, we do not write it, but you actually need to pull it from somewhere else. So that someone write it for you is called a Java util utility package. Okay, so that is actually package. So package usually is some sort of a collection of classes that people already write it down. Okay, and usually the package name always be lowercase. Okay, or be lowercase. So this one, I think that you may know it already. So let's move on. Okay, so that's the package. So package is like a book, a library. Okay, you have a collection of the classes, and class is the minimum unit of a program. Okay, a minimum unit of a program is class. A program of minimum size should at least be a class. There's no more smaller program. Okay, that is a class. So class, okay, class, you have the compilation flow. Okay, compilation flow such as here we do have, let's go to there. Okay, let's go to the directory. I'm teaching a little bit slower than normal review class, okay, because normal review class, we may go faster than this, okay. So let me delete this data class. Okay, let me delete this data.c text. Okay, let's just keep the source file. Okay, so at this moment, we only have, so let me cd to here. Okay, cd to this wigwag. Okay, put it over here. So I do change the directory to the program side. Okay, so this one is DOS prom. DOS prom actually is right at this current package. So right here, I have a program called data. So in the DOS prompt, I can type data.java. So data.java is a source file. It's the one that I actually edited in Blue.j. Okay, so that is a program. Okay, that's a program. So now I need to compile it. So I use Java C to compile this data.java. Okay, I compile it. So originally I have this source code file. This one we call it source code. Okay, the Java file is called source code. Source code is you write it in Java language, is source code. So after that, you actually generate a program, a bytecode program. Okay, so let's look at the bytecode program. So right here, you do dir, check the directory. There's a data class being generated. Okay, so the data class being generated. You try to look at it, you kind of cannot see what it is. So let's type this one, data class. You don't understand it because it's in bytecode. It is in binary format, so you don't understand it. That's normal, okay? But here, first one you use a Java C, that's Java compiler. Now you do run it. So run Java data. Here you get the result, okay? Okay, so that you run the program. So basically, first step, you compile to bytecode, and then bytecode being loaded to Java virtual machine. So Java C is Java compiler. Java is Java runner or Java virtual machine, okay? Or Java virtual machine. So here you have Java virtual machine. You run that program, okay? You run that program, and then you get the result over here, okay? So the thing is that your program will be loaded by the class loader, okay? By the class loader, and it will load to this memory, Java virtual machine memory. We will come back to this chart later, okay? But at this moment, you know that you have a Java language will be loaded to here. Now, next one, your program may have some data over there, some program over there, okay? We'll come back to here later, okay? So let's look at the data type, okay? So data type, you have Boolean, byte, short, char, integer, long, float, okay? So what you need to be tested is only the double, integer, character, and Boolean. Only these four types will be tested, okay? So integer is 32-bit, okay? Integer is 32-bit, okay? And character is for symbols, okay? Character is for symbols. Double is for 14-point number. Boolean is for true or false, okay? So this kind of available, we call it, what? Primitive data type, okay? So primitive data type is like, okay, let's create another one. Here, let's create some class called circle, okay? So this is a circle class. We can declare some variable, okay? So public static, okay, void main, okay. Here we have a program, we test it, okay, we test it. So here let's assume that we're still using the import, okay, java.util.scanner, okay. So we kind of ready. So we create scanner, okay, input equals new scanner system.in, okay. So right here you create double, okay, double radius, okay, radius equals input the next double. So we read in the double value to radius, okay. So here you need to have system.out.print, okay, and here you should ask people to enter the radius, okay. So with that you get the data in, and then you do double, okay, area equals mass.pi times radius times radius. Okay. So this one math.pi is a constant. It's a constant defined in math class. So to define a constant, you can do this final, okay, static constant, okay, integer, okay, stat 20, okay. So this one is a constant. You declare a constant, and constant usually we want it to be all capital, okay. So right here, math.pi is actually is a constant called pi, but that pi actually living in the math class. So you calculate your area by the radius that you get, and then actually you multiply pi r squared to get area, and then you print out. Okay, so you print out the area. Okay, this is a program. Okay, this is a program that you write using the static method. Okay, using the static method. So here you run it, you enter radius. So let's put 3.0. You got the area. Okay, so this one I miss a colon. Let's put it there. So this one is a program that you actually write. Okay. So right here, one thing very important is that we have a radius, right? We have a radius. So radius, we do declare the data. Okay, we do declare the data. So a variable you need to declare before you can use. Okay. So declare means that you declare some double value. This one's data type, okay, the data type, and you have radius, okay, and this radius is a data called radius. So at this moment, we actually call declaration. So declaration means that you tell the compiler you have a double value called radius, okay, that portion is called variable declaration. Then you can assign some value to it. When you assign some value to it, that's called instantiation. Okay, that's called instantiation. So that actually is like you have the radius equal 1.3. So this one is so-called instantiation. Okay, you kind of initialization. So you initialize it. So basically, you declare a primitive data type. Okay. So primitive data type that you have, say an integer or a character, okay, or a 14-point number or double value or integer. This kind of variable, we call it primitive data type. You will declare a variable A equals 3. That means within A, the memory location, you put a 3 over there, okay? Then we have another type that actually is non-primitive data type. Non-primitive data type actually has string, array, or class. Okay, these are different data type. Okay, so let's assume that you have a string. Okay, string s equals ABC. Okay, this one. Okay, this one actually when you do this, when you declare an integer in your function. Okay, when you declare your char flag or double radius, what will happen is like in your memory, okay, in your stack right here, main function, you will create a double value, actually say radius, will be assigned with 3.0. Okay, that is put into the stack. Okay, but reference data type is different. Reference data type, you will create a object. Okay, you will create an object. So let's try this one. Okay, let's try this one. So here, reference data type is like you may have string x. Okay, let's try to check a string. Okay. Okay, here we have a string s that we can assign ABC to it. Okay. So this S string is actually reference type. So reference type means what? You create this string. So this S actually is within your call stack. There's a string, but you do not put the ABC here, okay? Because ABC is too long. Sometimes it's not ABC, sometimes it actually is A, B, C, D, E, F, G, H, I, J, K, and very long. And very long, so it's impossible that in your step, you put the whole thing, A, B, C, D, E, F, G, whatever in there, impossible. So this kind of variable string type, we call it reference type. So at the runtime, you actually do not put a value here, okay? You do not put a value here. Instead, you create a string called A, B, C, D, E, F, G in the heap area. Heap, we call it dynamic memory area. So in that area, you put your string over there. And right here, you are S only pointing to here. So indirectly, you actually pointing, indirectly, you pointing you use the S to access the data, okay? This type of variable, we call it reference variable. So your string is a reference type, your array is reference type, okay? Your array is also reference type. This one is also reference type. Your class is also reference type. So something like, okay, data, okay, E equals new data. This is also reference type. So reference type, they will put the variable inside the heap. Okay, it's dynamic memory area. So stack used for local variable. Okay, heap for dynamic variable. Okay, method area for constants. Okay, so this chart, when we do multiple choice, I will explain how it works. Okay, but at this moment, remember that your string, your array, your user-defined classes, they are created at the wrong time. They are created at the wrong time, and they are indirectly access the data, and they are primitive type. Okay, so let's look at one more data type class. Okay, so here we do have a circle. Okay, so the circle, actually the circle class, we create a circle class. Okay, that circle class only one main function. Okay, so this same circle, I may create another class called round. Okay, round. So round is also another kind of circle. So this one I do not write it in the circles way. Okay, in the round I actually declare some variable, say double, okay, radius. Okay, equal 0.0. This one is an instance variable. Okay, and we have a constructor run. Okay, so double R. Okay, and we say this radius equals R. Okay, and then we can actually have this one. Okay, say public. Okay, double. Okay, get area. Okay, this one we actually will return. Okay, here I would like to declare my own constant. So final static. Okay, and then double. Okay, pi. Okay, let me call it my pi. Okay, my pi. My pi is 3.14159. Okay, I don't use the one from next class. So here my pi times radius radius. Okay. And I'll create a toString function. So public, okay, string toString. Okay, so here is a toString, and here I'll say return. Okay, and here I have a circle. Okay, circle parentheses plus. Okay, here would be actually radius. Okay, let's assume that this is the class I developed. Okay, so this one's run class. Okay, run class is a circle. Define a circle. Okay, so you have the constant, you have instant variable, you have constructor, you have a get area, you have toString. So this is the way you write a class, okay? So I originally have a class called circle. So now I'm going to create another one called test circle. Okay. This test circle will test the wrong class, okay? The wrong class. So I'm going to actually copy the code over to test circle, okay? So let me copy it over here, okay? And then right here, let me copy the main function over as well. So this one is pure testing class. This test circle is pure testing class. The wrong class is actually pure data class. So this wrong class is pure data class. Okay, pure data class. So my test circle right here, I enter some value that's actually put into radius. Let's put into R. Okay, put into R. So this portion, let me actually delete it. Okay, so I'm going to create something called run. Actually, circle C1 equals new run. Okay. Putting the R into here. So I do create a circle. So this kind of circle one, it actually is a reference data type. It is reference data type. So we create a circle of radius R in the heap dynamic area, and your C1 is only pointing to it. Okay, pointing to it. So at this moment, okay, it's C1 is a reference, okay, and the right-hand side is actually object. So you have a C1 that actually is a reference. Right-hand side, okay, right-hand side is an object. Okay, after that, we can do this one, system.out.print line C1.get area. Okay, so the C1, we can actually get an area and we print it. Okay, so this one test run. Okay, so enter the radius. So let's enter 3.0 and the area being printed. So this program compared to the circle is actually getting the same effect. Getting the same effect. So this one you have a data class called run class. You try to test it. Okay, you try to test it with the tester class. Okay. So the circle class do not have object involved. So purely working on the primitive data type. Okay, it's purely on primitive data type. So you kind of create a radius and calculate the area right away here. This one is a reference data type. So we create a class that has the data field, has constructor, have get area and toString. And we can test it over here in the tester class. So let's run it. Okay, this one we have 3.0. Okay, so let's actually run the circle class as well. Okay, you kind of enter it, but you still get the same result. So these two actually is the same. Okay, there is some difference in area because I use my pie is different from the master pie. Okay, there's a tiny area difference. Okay, any questions so far? Let me see. Oscar, have you any question?
No.
You have no question? If you have question, must voice out, okay? I can explain more. So right here, I tell you the difference between primitive data type. Primitive data type is you just have a radius. You directly put the data into there. Okay, you directly put the data into there. So let's try another way. Okay, let's try another thing. So right here, I test data, so I create a C1. How about this? How about I have a C1 equals new, okay, run. This time I do use 5.0, okay. And then I print out the C1's area one more time, okay. I print out the C1's area one more time. And then we test it, okay. So here I enter the radius is 3.0. But you get the what? Get the pi times 3 times 3, okay? and pi times 5 times 5. So basically this one is creating a new object. So what happened is, first one, you have C1 that has some reference. It pointing to an object of 3.0. And we print it. Then later you create another one, 5.0, and then you cut the reference from here and pointing to here. And when you get the area now, you're getting the area of this new wrong object. Is okay? This is a so-called reference data type, okay? Reference data type is like this. It's the way that we do it. So this test circle program, you can also copy it, okay? Put into the wrong class, okay? They are data, but you also put the tester into it, okay? But here we don't have a scanner, so let's actually put a scanner in, okay? And you compile, you can still run. So right now I don't use the test circle run, I use the run. You get the same thing, okay? You get the same thing, you can still get a radius 3.0, you can still get it. So here, the run is a data class, okay? So run is a data class, so basically it's actually a run class, okay? You can use to create circle 1, okay? And maybe circle 2 later, okay? And you can test it using the test circle to test it, okay? You may use a test circle to test it. You may also use what? Use a self-tester, the main function inside the run class to test itself. So the main function is self-tester. You can use a self-tester to test it. So right here, I'm going to print out system.out.println. Print is. This one, I will write it self-tester. Okay. So you can test by your own program. You can test by other tester. Okay. So right here, let me use a self-tester. So you will tell people it's self-tester, and I put in 3.9 this time. Okay. And I can also use this test circle. So this test circle, let me try to print out something. Okay. It is the same result. So let me actually put like this. This one we can call it driver tester, okay? So driver tester can use the driver tester outside. So this one is from driver tester. You get 3.0, okay? Here you actually can use the self-tester. So self-tester, you create it and you put 3.0, okay? So self-tester you can test. You can even create another class. Let's call it using run. Okay, so run become an object, so you can even using run. And right here, let's actually have this one have public, okay, static, okay, void name. Okay, right here, I explain more about reference data type, okay? Because I believe that a lot of students doesn't know what reference data type is. So right here, I can use a run C1 equals new run 2.0, okay, run C2 equals new run 3.4, okay, run C3 equals new run 4.3, okay, system.out.println C1. Let's copy this one for 3 times. You can kind of using the run class, data class as a data type, and then you can actually just run it. So using run is a program. It's a program, okay? So here you can also copy the get area to it. Okay, so let's actually copy the get area to it. Okay, so right here, let's actually do this. Okay, put it over here. Put it over here. Put it over here. Okay, C2 and C3. So these are creating reference data type and then use that as object to run. And you print out each circle and each area, circle and each area, circle and each area. Okay, this is so-called reference data type. So reference data type, you can create a class by yourself. That's a pure data class. You can test it from outside using tester. You can also use a self-tester. You can also use a other class to what? To use that run as a data type and create object for it. Any questions so far? No? How about you? Any question?
I don't have any questions.
Okay, so these are different data types. So we are going to move on, okay? Let's see, actually right now we are 7:26. So that has a 5 minutes break right now, okay? We are in the middle of sunset. So that's actually have 5 minute break. So come back on 7:32. Okay, so far we go through the different data type, okay? Go through the different data type. So there are a few type we will be testing in AP integer, character, and then Boolean, okay? So here, this chart is very important, okay? When you have two data type that work on some operation, so have integer, okay, plus integer, that will become an integer, okay? If you have integer plus a double, okay, you become double, you will use the wider type, okay, wider type, so you become a double type. Okay, right here, actually, if you actually have a string, okay, so string plus a double type will become a string type, okay. So string is even longer than double, okay. That's the basic definition, okay. So right here, also one thing is that if you try to actually have a double 3.0, you try to convert it to integer A. This one will have trouble because you actually kind of losing bits. Okay, you losing number of bits. So you can only do integer. A equals integer. You need to force it into integer format. Okay, losing bit, okay, but you not force it to integer. So this chart is used for that. Okay, your shorter type converted to longer type. Okay, longer type converted to shorter type. Now, okay, okay, and you have two integer plus an integer plus another integer, it become integer. An integer plus double, it become double type. Okay, a char added with the integer, it become integer. Okay, that's a rule. You use two operand, you use the longer type. If you convert from integer to double, okay, double to integer, no, now okay. You have to use the implicit conversion point, okay. So that one's data type. So basic program, we already discussed the basic program structure you need to have, okay. Your data field, your static method, your constructor, your methods, and your testing program. So testing program for class, this one actually is optional, okay. You can design something that actually is pure data class. You may not need that, okay. So this one is a class called charge, okay. It has the RX, RY, and the Q, okay, and the Q. And then there's a constructor called charge. And there are a few functions, okay. Any question about this class here? About Alan, do you have question? Hello. About Kyle, do you have question?
No.
No. So let me ask you a question, Kyle. Okay. So here, what's the purpose of constructor? What is the purpose of constructor? Kyle, hear me? Hello? What's the purpose of a constructor? Any question, any answer?
It creates the object, right?
For what purpose? What's the purpose of the constructor? Do you understand or no?
No.
No. The purpose of constructor is to build the object. Okay. You actually use new and then new wrong. Okay. So you should try to come out with some question. Okay. Since we are introducing the constructor and wrong, and you really don't know about constructor, you need to come out with question. Okay. Don't just actually stay there and not try to come out with question. Okay. Because this review, after this review, nobody is going to teach you what it is, okay? So you must use this opportunity. If you have any question, must ask, okay? Don't let the opportunity pass by, okay? So anyway, we have to continue, okay? We have to continue. So that's your job to come up with some question to ask, okay? Don't stay there if you don't really understand it, okay? And you are just wasting your time, okay? Next one, we have a function. A function actually would have multiplier, okay? So public or private, okay? This one determine who can see this function. And there's a return type, okay? Return type, if you write a void, that's not going to return anything. So void function, when you do return with 3, if you return with some value, you got 1 point deduction, okay? You got 1 point deduction. So right here, you have a function called potential at. Potential at, you give the so-called XY. This one is a charge model, okay? Charge model that actually is, you have a charge, okay, with Q plus, okay? So that is a charge Q, right? And in the 3D space, a certain point, XYZ, okay? There should be certain potential level of that one, right? Because you have the electrical force equals KQ1, Q2 divided by R squared, right? And your electrical field would be the KQ1 over R squared, okay? And you take the integral of that value d that dr, okay, d certain radius, it will become your voltage. That should be voltage level. It should be KQ1 over R. Is that okay? That's what people are calculating in this function. Okay, this is physics. Okay, this is physics. So that is the charge. Given any x and y location, you use the K constant. It's a KQ1 divided by the R squared. Okay, so this is returning a voltage. That's the one we talk about. Voltage is your KQ1 over R. Is okay? And R equals square root of Rx squared plus Ry squared. Okay, so that's the return value you got. That's a double value you will return. Okay, that's double value you will return. Any question on this one? Okay, that's the function. So function is a function name, function return type, and parameter. Okay, and some function you may have a potential function at a function, and you may use an integer x, integer y. Okay, that we call it overloading. Okay, we call it overloading. That means that this potential at can deal with double type data and integer type data, and overloading usually is happening in the same class. Same function name in same class, different parameter type, we call it overloading. Overriding is actually same class, same parameter, different class, same function name and same parameter list. That is so-called overriding. Okay, overloading and overriding very important. And right here, when you use the constructor to build a object, when you use a constructor like this charge to build an object, that data will be stored into your heap area. Okay, if you actually declare some variable, say double K, the double K is a local variable that will be stored in the heap. Okay, I'm sorry, in the stack. So in the stack, all store the local variable. If you create some constant, those constant will be stored in master area. And these three different area is the one we talked about in the beginning. You load your class, those variable will be distributed to these different memory locations. Okay. At this moment, you still not get used to this. Please try to understand. Okay. Later, when we explain the problem, you will see that. Okay, why we use this. Okay. So that's that. And we have some static variable and some non-static variable. So say here you have a bank account. So bank accounts balance actually is per account. So every account you have different balance. Okay. So that's actually is instance variable. Okay, that actually is instance variable. So just like our run class, we do have a radius. So circle 1 has its own radius. Circle 2 has its own radius. So this radius, we call it instance variable. So instance variable don't put the static before it. So don't put a static before the instance variable. Okay. There is another variable that's actually say myPy. MyPy actually is share variable. Every object OC, circle 1, MyPy is the one value, circle 2 is the same value. This kind of variable is share variable. In those class variable, we use static double and then MyPy. So remember, static is for share property. Non-static is for instance property. Okay, that's what we try to say over here. Okay, remember this. Okay, this is very important. Static is for class variable is share property. So when you have three functions, they will actually access the same data. Okay, from different objects. Okay, your non-static one, it will say balance. Each bank account has their own balance. Okay, but that's assign account number, that number actually is shared. Everybody see the same one. Okay, so the data being stored in different area. So right here, if you use the constructor to build an object, new car, the new car will create a car in the heap. And the car, she actually is a local variable that's stored in stack. So this one's the heap. This actually is stack. Stack is in your calling stack. Okay. So that's different location you see the variable. So arithmetic, you have plus, minus, time, division, and modulus. Okay, more important part is this division. Okay, so when you have 17 divided by 5, you end up 3 times 5, remainder 2. Okay, so 3, we use 17 divided by 5, you get 3. 17 divided by 10 modular by 5, you get 2. Okay, that's a modulus. So modulus is the remainder that you get after the division. Okay, that's modulus. Okay, but if you do have a 5.0 divided by 2.0, you will get 2.5. So in this case, you do have 5.0 divided by 2.0, you have 2, okay, 4, 1.0, and 10.5, 10. So you get 2.5. So double divided by double, you get double, okay? And double divided by integer, you get double, okay? Integer divided by double, you still get double. So if there is an operand that actually is double, you get a double. And only when you have two integer divided by integer, you get integer. At that moment, we call it integer division. Okay, and integer division is a concept often tested in AP. Okay, often tested in AP. So here we do have increment and assignment minus. Increment is increase. Okay, you will increase the data. Okay, increase some data. So A plus plus means okay, A equals A plus 1. Okay, it means that plus plus A is similar, but plus A is not tested in AP. Plus equal means so A plus equals 1. It equivalent to A equals A plus 1. Okay. A plus equals 3. It is equivalent to A equals A plus 3. So this one we call it augmented assignment. Basically, you are added by 3, minus by 3. Okay, minus equals minus by 3. So A minus equals 3 equals equivalent to A equals A minus 3. Okay, that's minus by. Time by actually is multiplied by. Okay, so A times equals 3 means A equals A times 3. It's multiplied by 3. Okay, A divided by 3 equivalent to A equals A divided by 3. Okay, this is divided by. Okay, so this operand must remember the purpose and how to use it. Okay, so this one we go for. So when you check the multiple of n, say you check whether m is multiple of 2, you use n multiplied by 2 equals 0. If it's equal 0, then it's a multiple of 2. Okay, and this is used to test the leap year and also the GCD algorithm. Okay, the greatest common denominator program. This one, okay, this one we will talk about it later. Okay, talk about it later. That's too complicated right now. Okay, so the first algorithm I'll introduce in this chapter will be the reverse of digit. Okay, reverse of digit. So let's look at the program called reverse of digit. So reverse of digit is an algorithm. This one commonly used. Okay, please remember the algorithm. So right here, please remember it. Okay, so you have an integer, we will do reverse of that integer. Okay, so we are getting the n. Okay, so let's assume that this n that we try to reverse is actually 1, 2, 3, 4, and the reverse result will be 3, 4, 3, 2, 1. Okay. That's why what we want to return reverse. Okay, so here if n equals 0, you return 0. Okay, n equals 0, you do not need to return reverse it. So that is 0. So then we have the integer r. R is the data we want to return. So let's actually set it to r, set it to 0, and at the very end we will return that r. Okay, so r is the value we want to return. So now, while n greater than 0, okay, we do the following thing. So we have 1, 2, 3, 4. So we want to reverse it. So we get the 4 first. Okay, get the 4 first. So we will get the digit d equals n 10 modular by 10. This one is getting a single digit. Okay, so ones place. Getting the ones place. So right now it's actually 4. Okay, this 4. Okay, we get 4, and next time the loop come back, we get 3. Okay, so at the very end we actually do n divided by 10. Okay, so what happened is like every time we get a digit, that's 4 first time, and then n divided by 10. Then divided by 10, we get a 1, 2, 3. So the second time we get 3. Okay, and we actually divide by this, so n becomes 12. Third time we actually get the 2, and then we get the result 1. And fourth time we get the digit that will be 1. So every time the d actually is getting 1 digit at a time using this algorithm. Okay, now the first time I have a 4. Second time I have a 3, right? So 3 need to put to the right side of the 4. So we will do this. We will do R equals R times 10 plus E. Okay. What this one is actually what this one is actually originally you have 1, 2, 3, 4. So you get a 4 first, right? And then you put a 4 into your R, right? Second time I get a 3. Get a 3, I want to convert it to 43. So my 4 need to shift to the left by 10. So that R need to times 10 plus your 3. Any question here? Aline, are you okay? Hello, any question here? Hello, any question?
I have a question.
Yes.
Would it be possible to do this also by converting that into a string and then traversing that string?
Yes. That's another way. Okay, that's another way we can do it. We will talk about it later. Okay. So this is one way you can solve it. So we can do this one. But that is not in general can solve all the problem. Okay, but that actually is a good idea that you actually try to use string. In this reverse of the number is actually good. Okay. Okay, let's actually look at this one. So we have a system that out that print line. Okay. And here we can print out our reverse of 1, 2, 3, 4. Okay. This one must be a static function. Okay. Static function can only call static function. So this one we will have the reverse of the digit. Okay, go to 4, 5, 3, 2. Okay. The one you suggest, yes, that actually will work. Okay, so you have the public static. Okay. Integer reverse. Okay, integer n. This one is by the help of a string to do reverse. Okay, but it only works in this case. Okay, so let me call it reverse S type. Okay, so here you create a string. String equals n. A string S equals empty string plus n. That one convert the number n into a string. Then you do the following. You do create a string R, and this string R is empty string. So you do this for integer I equals 0. Okay, I less than s dot length, and then I increase. Okay, so right here you do this one your R. Okay, equals your R plus the S that character at I. Okay, I'm sorry. Actually, it should be the character at I plus R. So this one actually is a different order. So you get 1, 2, 3, 4. You get 1, 2, 3, 4. So the first character you get is 1. Okay, so you put it over there. Second one, you got a 2. So 2 need to put in front of the 1. So you get that. But eventually this one is a string. So you should return, okay, integer parse int. Using the R, you convert it back to string, back to integer. Okay. Is that okay? Hello, is that okay? Is that okay for this one?
I think that function has an issue. I think that function will be looking at the first one and just adding it.
Which one?
Never mind. I think it's fine now.
You need to convert it to integer, right?
Yeah.
Well, this one is not only doing this, okay? This one is reverse. Let's actually think about another one, okay? Let's jump to some other topic, okay? Jump to some other topic. Now we want to look at the number system. Number system is openly tested, okay? Number system is openly tested in this AP course, okay? So we may need to try to here. We may need to study the number system. So we have binary system. We will convert it to decimal or hexadecimal. So you need to remember this table, okay? So you need to remember this table. But here we are going to try to teach you how to convert the decimal to binary, okay? So to convert a decimal value to binary, we do need this, okay? We do need this. We do use, say, 57, we convert it to binary. Divide by 2, I get 28, remainder 1. Divide by 2, I get 14, remainder 0. Divide by 2, I get 7, remainder 1. Divide by 2, I get 3, remainder 1. Divide by 2, I get 1, remainder 1. Okay, I'm sorry, this one should be remainder 0. Okay, so you read from here to here, you have got 1, 1, 1, 0, 0, 1. Okay, so this one you will convert your decimal to binary. Okay, every time you take the remainder, okay, take the remainder on the side, okay, the quotient put it here, okay. Is that okay? Is that okay? 57 divided by 2, you got a quotient put it here, remainder put here, okay. And in the end, you sum up this way, you get that, okay. So let's look at this one. Look at this one. This one, if we want to write a program for it, okay, this one we want to write a program for it to get the binary conversion. Okay, this one actually, let's use the same class over here, okay. So this one we try to actually do public, okay, we convert to string type. Here is decimal converted to binary. So we get a number n, we try to convert it to binary, okay. So this one, if, okay, same thing, if n equals 0, we will return a string with 0, okay. If not, okay, we would have a string that is return string is empty string. At the very end, we return R. But right here, we would have while, okay, n actually greater than 0. We will do the following thing. Okay, we will do the following thing. We will get a bit. So integer bit equals the n take modular by 2. Okay. Every time your n will divide by equals 2. So that is from 57 you get 28. Okay. And this one you get a remainder as b. In the middle, you actually your r. Okay. So your first bit is 1, right? Then you put 0. So the next bit you have should be put in front of it. So your current R will be equal to your bit plus your original R. So this one will complete decimal to binary conversion. Is that okay? So if you look at this algorithm, let's actually cut this one to stay closer to my reverse. It's almost the same, right? Almost the same. Except the operation here is different. Divisor is different. Otherwise, the algorithm is same. It actually recurs successive reduction. Okay, successive division. So right here, let's do system.out.print line. This one print out of the decimal to binary conversion of 57. Okay. This one must be a static function. It should return, I'm sorry, it should return, it should be static, okay. It is static. So let's compile this one and run, okay. You get the binary version of this. Is that okay? Is that okay? Any question? So this successive division is very important, okay, very, very important. Okay, very, very important. It's used in many, many locations, situations, okay. It is used in many, many situations. So that is the function we have, okay. Now you also need to do binary converted back to the so-called decimal. So you, for each digit, you time its weight, okay, times this weight, you will get it, okay? So let's go back to convert the 57's binary value back to decimal. You have 111,001, okay? So this one weight is 1, this one weight is 2, this one weight is 4, this one weight is 8, this one weight is 16, this one 32, okay? So time this one, you got 1 plus 8 plus 16 plus 32, okay? So this one is 57. Is that okay? Any question? This one's a conversion from your binary back to conversion of your binary back to the decimal value. Okay. Any question? So these are the so-called because we are in the review, okay? So if you have question, you must voice out, okay? Don't just stay there. And this table, binary to hexadecimal or to octal, is every 4-bit you can convert a binary to hexadecimal, okay? Every 3-bit you can convert a binary to a octal digit, okay? So over 10, you put A, B, C, D, E to there. Okay, so this one is the conversion. Any questions so far? Any questions so far? Okay, that actually is the so-called data type conversion. Okay, so we do go to the operator and show you how it is useful in using the reverse of digit, okay? And we also convert this one to decimal, okay? Merging of the two array, okay? We will talk about this later, okay? Merging two array is actually talk about this later. Let's look at Java arithmetic first, okay? Now merging of two array, probably too hard right now, okay? So let's look at the Java operators. So we have this Boolean relational operator. So let's then create it, okay? So remember not to use the method symbol, okay? And then here we have Boolean value, Boolean constant, Boolean method, and Boolean expression, okay, that you can use. Okay, so one thing that you need to know is like short circuit, okay? Short circuit means that if you have some Boolean expression, okay, the first part is already false, then you don't need to check the second part. So if the denom is already 0, you try to work on actually 3 divided by 0. 0 is the denominator, okay? So this one, if you have that, you try to divide it. This one, if it's 0, the second part will not be evaluated. We call it short circuit because first part already false. For false and anything is actually still false. So we will stop evaluating the second part. So you won't go into the division by 0 problem. You won't, okay? So this one is called short circuit. So if you have 3 Boolean condition, A and the B and the C, happening at the same time, then your A is already false. Then your B, C, you don't need to evaluate, okay? But if your A is true, and then you will evaluate B. If your B is false, then you don't need to evaluate C. But if your A and B are actually true, then you will evaluate C. So that's a rule called short circuit, okay? For OR, if the first one is actually false, you will evaluate the second part. If the first one is true, the whole thing already true, so you don't evaluate the rest of the expression. Is that okay here? This is called short circuit expression. How about William, are you okay? You hear me? Hello, hear me?
Yeah, we're good.
So any question about this short circuit? Okay, must pay more attention, okay? This is very important. Now, next one, we have the Boolean expression, okay? Boolean expression, and we sometimes use a Boolean operators. So this Boolean algebra, one important thing is the De Morgan rule, because we are review, so we don't have the time to prove every single one, okay? So I will actually look at the De Morgan rule, okay? De Morgan rule is something like this. We have A or B, okay? So in Java, we write this down this way, A or B, okay? So in Boolean algebra, we use a plus sign. So A or B bar, okay, in Java is written down in this way. It would be equivalent to you actually breaking the bar, change the operator from plus to end, okay? So it's something like this. So it actually is A bar and the B bar. So it actually should be converted into not A and not B, okay? So this one's called what? De Morgan rule. Let's try a real example. So here we have A greater than 3, okay, or B less than equal 4. This whole thing's not operator, okay. It is, you can actually look at it in this way. So you have A greater than 3 or B less than equals 4. Okay, the whole thing take bar. You break the bar, change the or to end. So that will become A not greater than 3 and the B not less than equals 4. This whole thing will become A less than equals 3 or, and B greater than 4. So eventually this red one equivalent to this one. Okay, this one is to prove that, okay, sometime in the Boolean operation, you need to convert it in this way in order to be able to find out which one you should pick in multiple choice, okay? This one's called De Morgan rule. Let me try one more time with the end, okay? So here, if you have end, so you have A and the B bar, you should break the bar, convert the end to or, okay? So you become not A or not B, okay? So in written in Java, that this time let's try X, okay, less than 2 and Y greater equals 4, okay? This one's negation should be equivalent to, that's actually using the Boolean expression. So X less than 2, okay, and Y greater equals 4 bar. So you break the bar, change the operator from and to or, so it becomes or, and you have X less than 2 bar and Y greater equals 4 bar. This one equivalent to X greater equals 2 or Y less than 4, okay? This one equivalent to this, but we try to use a De Morgan rule to find different operation, okay? This happened on this AP exam many times. I would say every year, at least 1 to 2 problems will test you on this De Morgan rule, okay? Any question here? Just break the bar, change the operator's type from end to or from or to end, okay? Any question? Okay, this one is De Morgan rule, okay? So that's that, and then, okay. So then you need to take care of the if then statement, okay, if then statement. So if there is an else, we call it dangling else. We cannot determine whether it's this red if or black if, okay? Remember the else belong to the closer if, so it belong to this red if. It doesn't belong to the black if, okay? This is called dangling if, okay, dangling if. So you can have a loop to repeat several times, okay? Repeat several times, okay, it's while loop, for loop, okay? Remember, continue will be breaking the rest of the iteration. Break will breaking the rest of the loop, okay? Okay, this one is for loop and while loop. So this one we just kind of go through it. Okay, go through it. So let's actually try to work on some of these patterns. Okay, some of these patterns. So first one is looping for many times. So this kind of the so-called algorithm, you need to remember it. Okay, so this first one is actually A1. Let's call A1 repeat. Okay, A1 repeat. You need to try to remember it. Okay, here because it's easy, so I try to recreate it. Okay, so public static void. Okay, so repeat. So repeat a string s. Okay, for integer n time. Okay, so we will do this one for n time. So for integer I equals 0. Okay, I less than n. Okay, I increase. Okay, so this one will repeat printing the s for n time. So system.out the print line, print out your s. This one will print out the string for n time. Okay, so public, okay, static, okay, void main. Okay. So here we will repeat. Okay, let's repeat actually a, okay, string for 10 times. So that's the repetition. Okay, that's a repetition algorithm. Remember that you need to repeat for n time. You do this. Okay, put in a number there and you do this. Okay, that's the first easy one, easy pattern. Here we give you this different pattern. Please remember that you will need that in your FRQ. Okay. Second, you actually may need to have a loop with counter. Okay, need to have a loop with counter. So that actually try to have a second one, A2. Okay, this A things means that you must remember. Okay, so we have a counter. Okay, so that's using down counting. Okay, so let's do using down counting. So here let's actually do public. Okay, static. Okay, this one let's call it breadth of. Okay, breadth of integer n. Okay. So we will be down counting until 0. Okay, so here, okay, integer, okay, I equals n. Okay, while actually I greater than 0. Okay, we do the following. Okay, I will decrease. Okay, I will decrease. Okay, so right here we will do system.out print line. Okay, and we say the number. I, okay, plus exclamation mark, okay, and we do down counting, okay, so this one no return, so we do void type, okay, we do down counting, and when we get out of the while loop, it actually exit condition is I will be equal 0, okay, so right here you get out, and at the very end we do this, we do system.out print line, we print out, okay, 0 exclamation mark and the rest of. This is like rocket. Okay, it's like rocket. So right here we have public. Okay, static. Okay, void main. Okay. So here you must remember this different simple design pattern. Okay. So here, okay, rest of 10. Okay. I'm trying to create this different simple one, and you should remember them. Okay, so after class, please remember this simple design pattern. So you down counting from 10, 9, 8, okay, whatever, down to D0 and then press stop. This one is a down counter. Okay, down counter. So that's number 2. Number 3 is sentinel loop. Okay, sentinel loop is actually when you are writing a program, you may need to have a sentinel loop. Okay, so right here, let's try another one. A3, okay. A3 is sum loop, okay. So there's a sum loop we want to actually do it. Okay, so right here, let's have import, okay, java.util.star. We get the scanner in, okay, so we do public, okay, static, okay, void main. Okay, so we need to have the so-called a sentinel. So right here, let's have the sum equal 0. Okay. So here I declare scanner input equals new scanner system.in. Okay. I declare this. Okay. And then here I would have, okay, I would have a Boolean value called done equals false. So here while not done. Okay. While I'm not done. While I'm not done, I'm going to do the following thing. Okay. So here I'm going to do string. Okay. Actually x will be equals input the next line. So here if actually x dot equals exit. Okay. If we equal exit, then I will do this. We will do break. Get out of the program. Okay. So right here, I'm going to actually convert it to lowercase. So that uppercase will also be converted to lowercase. So you can type exit or any type, and you should be okay. Now if you are not exit, I'm going to create a integer d, okay, will be equals integer that pass int, okay. So I'm going to pass in the x to an integer, and my sum will plus equals the d, okay. That's it, okay. That's it. And here actually, okay, this one is okay. We can actually do this one. We can do done. We can set the done to be true, okay. Done to be true, and this portion actually we can do if not done. Okay, if not done, we do this. Okay, if not done, we do this. If done, we will bypass. We don't do this. Okay, so here this one is an example of sentinel loop. Okay, sentinel loop means that we guard against the exit. Only exit can break the loop. Okay, so right here we do system.out.println. Eventually we get the sum. Okay. So let's try this loop. This loop is a sum loop. So we actually get 1, 2, 3, and exit. Okay, so you get 6. Let me try one more time. I forget to actually prompt them to do input. So enter. Okay. So here you should use this prompt. So enter an integer. Okay, so or exit, okay, or exit. So tell people that we can enter an integer or exit. Let's try one more time, okay? So right here, let's actually run it. Okay, so 3, 2, 1, 10, and then exit. Is that okay? You got 16. Any question on this one? Sum loop? That you need to have a sentinel condition. If that condition happens, you break the loop. You break the loop. You can use a break, or you set the done to be true and get out. So if no done, if not done, you continue to get a new value and actually you continue to get a value and add it to sum. You continue to get a value and add it to sum. Okay. Amy, is that okay?
Yeah.
Is that too hard so far or no?
No, it's good.
You okay for you? If too hard, must let me know. Okay, I try to actually drop the difficulty.
Yeah.
Okay, next one. Okay, combine. Okay, this one is okay. We actually don't need that. Okay, you can create multiplication table, so we don't need that. Okay, nested loop. Okay, nested loop. We will do 2D. We will do it. Okay, that's next one. Let's try. Okay, let's try this one. A loop. Okay, let's try this. Okay, let's try this nested loop. Okay. Before we do nested loop, let's try the multiplication table loop. Okay, this one in the regular class we should actually teach you, but here we have a multiplication table. Let's actually create multiplication table. So this A something will contain the algorithm. You must remember. Okay, you must remember. So here let's actually create some multiplication table. Okay. So here that's called public, okay, static, okay, void empty multiplication table. Okay, so right here we would have for integer I equals 0. Okay, I less than 10. Okay, so basically come from 1. Okay, 1. Okay, and then I increase. Okay, so here you set out the I, and then we can have integer. Okay, j equals 1. Okay, j less than 10. Okay, j increase. Okay, so this one you have I and j, and we do this system.out print. Okay, print f, and we print f, and then we do percentage 3d. Okay, comma. Here we have I times j. Okay, so we print out I times j, and every time we print out change line. So here you will print out 1 times 1, 1 times 2, 1 times 3, okay, 1 times 4, continue, okay, until you have 1 times 9, then you change line. Okay, so this one you will print you the multiplication table. Okay. Okay, good. Okay, good. Run it. So we create a multiplication table like this. Okay. Now next one. Next one, if we want to print out this British flag, right? British flag. So we will try to print out the British flag, and you will do something like this. Okay. So let's look at it. You have the multiplication table. So basically, you create I as a row, okay, and J as your column, okay. So basically, you are going to try to draw this line and draw this line, okay. So when you draw this line, it is what? I equal J, okay. So when you draw this line, is what? It actually is, this one you may have 9 and 1, okay, 9 and 1. So 9 plus 1, this one should be 10. So sum equals 10. So I plus j equals 10. Okay. In the middle, you have I equals 5. You have j equals 5. Okay. So let's try to copy this multiplication table program to the British map program. Okay. Copy this one. So that actually do A5. Okay. This one called index space. So we create index space using the I and j to do it. Okay. So the copy here. Okay. So here let's call this function British. Okay, so here, remember the change line, still change line. Here is about your printf. Okay, printf, this one we will just doing print. Okay, so print with star space star. Okay, so this one will do print like this. Okay, so when will we print? Okay, when will we print? A few conditions we will print. If I equal j, we print. Okay, or I plus j equals 10, we print, okay? Or I equals 5, we print. Or j equals 5, we print. Okay, this different condition will print it. So this one is actually your I come from 1 to 9, your j come from 1 to 9. When actually I equals j, you are going to print this line. When I plus j equals 10, you're going to print this line. When I equals 5, you're going to print this line. When j equals 5, you're going to print this line. So basically, this one create an index space to print a map like a British map. Okay, so let's try this one. Okay, sorry, it actually is wrong. Okay, let me try one more time. Here the index space. So here actually I equal j. Okay. Okay, here I forget. Okay, so otherwise, else we system.out. Otherwise, we still need to print something. If not printing the star, we print 3 spaces. Okay, we print three spaces. Okay. And you will print out this format. Is that okay? So basically, index space program showing you what? Showing you that you use the row and column I and J. Okay. If I qualify to print a star, you print the star. Okay. If not, you print the spaces, 3 spaces. Okay. So basically, you are designing this British flag using 3 as a box, 3 as a box. Okay. You're kind of divided it into 3 as a box. Okay. So you either print a star or you print 3 spots, 3 empty box. Okay. By using your right value of I and J, you will be able to print out this flag. Any question here? So in the AP exam, you might sometimes use this kind of algorithm to deal with the index spaces. Okay. Any question? Hello, any question? No question? Okay, no question, let's continue, okay? Okay, that's about it. Histogram, I think is too hard, so I'm going to skip it, okay? Because I do not hear the response. I think that one, if I teach it, that will be too hard. So here we actually finish the week 2, okay? So what I will do is right now, okay, instead of teaching too many algorithms, let's go back to our week 2, okay? Working on the balance, working on balance quiz problems, okay? So let's look at this one, okay? So you will learn some exam taking skill for multiple choice, okay? So let's see that actually, okay. So this one is a 1, 2, 3 problem, okay? So Amy, can you tell me which one is the answer for this one?
Number 3. So D.
Okay, you pick number D. Okay, let's check, okay? Okay, so first one, you have double X and then Y equal X. So here you have what? You convert a double to integer. So this one will cause error. So this one will cause error. So 1 will cause error. Let's see. Will cause an error message. You convert an integer to it. Okay, so you will actually cause an error. Let me see. Which of following pair of declaration will cause the error? Okay. So actually here one will cause error. Second one, you have a double use integer type to force it to it. So this one, no. Second one will not cause error. Third one have an integer converted to double, shorter form converted to longer form. So this one, okay. So basically problem, this one's B1 only. Is that okay? Amy, is okay?
Yeah.
So this one show you that our slices do have cover this. Okay, we did cover this one. And let me see, let me bring up my slice. Okay, one more time. Sorry, I kind of close it. Okay, so this one actually showing you this table. This table, when you convert a double type to integer type, it will cause error. Okay, so that's that. Okay, problem, this one. Okay, let me close this unnecessary, unrelated slices. Okay, so problem 2. Let me have Damon. Okay, Damon Wong. Can you try this one? Problem 2.
Number 2.
Yes.
E.
Okay, number 2, basically you kind of need to deal with the escape sequence. Okay, the sequence when you have double slash, you actually should, it is actually be a slash, okay? So double backslash is a slash, okay? This one, it will change line. So basically change line once and then have a single slash. So D is wrong because this double slash only used for one, this is wrong. This one, actually no slash is wrong. This one, actually, there's a backslash n or change line. This one, no change line. This one, no change line, no slash. So the answer for number 2 will be E, okay? So here we go over it just because that I want you to try it, okay? Number 3, let me have Eric U, okay, Eric. So what would be the answer for this one, number 3? How you solve it, okay? Tell me how you solve this number 3.
I think for number 3, the correct answer would be A, and an arithmetic exception will be thrown since you're dividing by 0.
No, actually, if you have a 0, the first portion is not equal to 0, so this one already false. So this one is short circuit theory, you go to the 2. Okay. So the answer is D, okay. The answer is D, statement 2, but not statement 1. Is that okay? This one in the class, we discussed the short circuit theory. Okay. There is a division by 0, but you won't go to there. You won't go to there because of this short circuit theory. It's exactly the same as this one. Your denom equal 0. So when it is equal 0, this part already false. False, you go to here. Is that okay?
Yeah.
So you won't go to here when it is 0. This is a so-called short circuit theory. Must remember this, okay? This one actually happened in the problem set many, many times. Every year, almost, I would say maybe one problem every year on this short circuit, okay? Must remember that, okay? Number four, let me have Katie, okay? Katie Wei. So number 4, what's the answer for number 4, okay? Hello, hear me?
Yeah, I'm like thinking on it.
Okay. So this one apparently is integer division, right? This is integer division, right?
I think it's E.
No, E is not. E, you already take the integer division. Okay, we are not fix the problem, yes. We are not fix the problem, it actually, yes. This is still in the integer division, okay? This one is an integer division, you must fix it, okay? But because you take the integer division first and then you convert it to double, not too late. That already returned 2, okay? So number 4 is E, yes, number 4 is E, you are correct, okay? That's integer division. You not only need to get it correctly, but also need to know what it is, okay? Okay, next one actually is number 6, okay, number 6. So number 6, let me have Lin, okay, Lin, try this one. Hi, Lin, number 6. Remember this one, addition and subtraction is higher than the multiplication, okay? It's not normal arithmetic, okay? So this one is really is 2 plus 3 need to go first, right? And then actually it will do 7 minus 4 need to go first. And then plus 8 need to go first, okay? Is that okay?
Yeah.
And then after that, you do 2, okay, 2 plus 3. So this one actually you times 12.
So would it be 5, like C?
And divided by 7. Is that okay? So you need to come up with such a chart to solve it. So let's see. Here you do have, let's assume that you have this one, you go first, okay? So this portion you get 7 minus 4 plus a, 7 minus 4 is what? 3, 3 plus 8 is 11, right? So this portion is 11. The front part, 2 plus 3 is 5. 5 times 12, you got 60. 60 divided by 11, you got what? You got 5?
Like 5 point something, but then it would be like 5 because
So 5, you actually, let me see. This one's a number 6, okay? So actually is C, is okay? Okay. Okay, number 7, let me have Natasha, okay, Natasha Chen.
Is it B?
Which is true the following Boolean expression given X is available type, okay, you pick B, okay, let me see if that's correct or not. So given X is available type of double, X is double, the whole thing is double trying to check equality, you may fail because of rounding effect. Because you may have a 3.0 compared to 2.9999999. Okay, so it will always evaluate to true, but actually it's wrong. So you value to force for some value of X sometime. Is okay? Is okay?
Yeah, I said
When
B.
you do some operation, it may, yeah. Okay, thank you. Number 8, let me go to Oscar. Okay. Number 8.
Well, let me read it. Sorry.
Yeah, read it. Yeah, take your time. No rush. Got the answer?
Would it be D?
Guys, D actually the same reason as the previous problem. They have numerical error may cause you not equal. Is okay? Okay, number 9. Whenever you try to compare two floating point number that or double number, you will have such error. Okay, you may have such error, may or may not, but okay, they may be. Number 9 have William Chai, right?
Yeah.
I'm sorry, your last name is not Chai, okay?
Jai. Yeah.
Chai, okay, sorry for that. So here, let me see, what's number 9? What will be the output of the following poorly formatted one? Okay, poorly formatted means that it may be correct, but it's poorly aligned. Okay, so remember what I told you. It is the dangling if problem over here. Okay, so what if the input value is actually 22?
I think it should be A.
So basically 22 put over here, greater than 0, yes, greater than 0. So here you actually is if something, then if something, and then else something, right? So go to here, you will get take modular by 5 equals 0. It is a multiple of 5? No, it's actually 22 is not multiple of 5. Okay, so you will not printing anything over here, right? You will not go to here, you will go to the else portion. Else portion will say 22 is negative. Is that okay? So number 9 actually is D. Does that make sense? This check if it's multiple of 5, but it's not. It's not, so you will go to else. So basically you go to here, it's greater than 0, yes. So you try to list if else portion. And then it is multiple of 5, no, it's not. So you go to the else part. So that's D. Is okay? Hi, William, is okay?
Yeah.
Number 10, let me go back to Amy, okay? Go back to Amy. So number 10, what's the answer for number 10?
Okay, give me a second.
This one is actually purely tracing the program, okay? So in this kind of problem, let's actually do it together, okay? I think it take you a lot of time. So we do have the x equals 30, right? So if you try to solve such problem, you need to write on paper like this, okay? S greater than 0, greater equals than 0, yes. S is greater than equals 0. So actually the else portion basically useless. You go into here, x less than equals 100, yes. So you only need to take care of this portion now, okay? Y equals x times 3. Okay, so y updated to 90, okay? If y less than 50, no, it's not going to do anything. So you end up with 30 and 90. The answer is A. Yes, you are correct. Okay?
Yeah.
So this type of problem, you basically try to draw some diagram like what I have. It should be fine. Number 11, go to demo, okay? So the following evaluate to true only if the Boolean expression, which one will be true? Okay, we'll evaluate to true only if what? They are all false. So basically it is what? This one tells you which one equivalent to A bar and the V bar and the C bar. Using De Morgan theorem, you should get A or B or C bar. That is C. Okay, I solved it for you. Is that okay?
Okay.
So must remember the De Morgan rule well. Okay. Is that okay? Connecting the bar, changing the operator from N to OR. You quickly will pick this answer if you know De Morgan rule. Okay. Then I'll give you one more chance. Number 12, similar type of problem.
Number 12 is
Both are integer.
think D.
D, let's actually check it, okay? So this one, left-hand side is A greater than B bar. A greater than B, okay? Left side is A greater than B. A greater than B and A times B greater than 0. What does it mean by A times B greater than 0? What does this tell you? Or what does this tell you?
They're all positive.
Both same sign, okay? You don't know,
Oh.
but you can only say it's the same sign. A times B greater than 0 means same sign. A times B less than 0 means different sign, okay? So you can only learn that it's actually same sign. Same sign A greater than B, so you end up with A is either A greater than B greater than 0 or 0 greater than A greater than B. Is that okay?
Yeah.
So what is always true is number 12. If B greater than B, then A will also be greater than B. Is that okay?
Yeah.
Yeah, so D is the answer. Is that okay? Okay, number 13. Number 13, go to Eric Yu, okay? Number 13. So we try to teach you theory, but I try to go over this given problem with you, trying to make sure that you understand, okay? Okay, which of the following guarantee that the expression is true? How to make it always true? Okay, so Eric, how to solve this problem? You have
I
A
think,
or B, right? So if A always true or B always true, this one is always true, right? One of it always true. So which one always true?
I think A is the correct answer.
Okay, so here you have a force. So here, if this one always a force, okay, then this right-hand side will always be true. Is that okay? So that's the way you pick it. Yes, that one I think number 13 is A, because you need to find somewhere either A left side is always true or right side is always true. Right side has the exclamation mark, so that means the right side take out the exclamation mark. This whole thing should be always false. Always false means that one of them is always false, it will be false. So this one always false is the right answer. Yes, number 13, A is the answer. Okay, I'm trying to give you a way to pick the answer quickly. Okay, number 14. This one has had Katie. Okay, Katie. This one. Which of the following in the following segment you may assume that A, B, N are all integers. Okay, what will happen if A equals B is false? That means that A not equals B. A not equals B. What will happen?
By giving you a second.
A equal not equal B means what? A equals B is false. So this part is actually A not equal B is true. True, you evaluate this portion. Okay, but this portion we already said that A equals B is false. So you won't go into the division by 0. No, you won't. So basically, it will depending on n take modular take n divided by A minus B greater than 90. You will determine which one you were wrong, right? So this one, you should get what? Number 14, C either way. Is that okay? Either way, both have the chance. Okay, good job. Okay, next one, Lin. Okay, number 15, Lin. Given n and count both are integer, which statement is true about the following code segment? Okay. N greater than, both are integer, okay. What's wrong with number 1? Okay, N and count are both integer. Which statement about is true? Okay. So first one, you count from 1 to N, inclusive, print N. Second one, you have count from 1 to N, also inclusive. So these two are what? These two are what? Always equivalent or always equivalent with some condition. Which one?
Would it be A?
Yes, number 15 is always equivalent under all condition. Is that okay? It's A, yes. Number 15 is A. Number 16, let me have Lin, okay? Number 16. The following fragment intends that a user enter a list of positive integer at the keyboard, terminate the list with Sentinel. Okay, so Sentinel is a special value that will turn out the loop or do something. Okay, so here is saying that the fragment is not correct. What is wrong with this guy? What's wrong with this guy is actually Sentinel is a constant. Right? Sentinel is a constant. And then here you want to process the positive integer. Okay. So basically this is the one similar but not the same. Similar to my adding sum program. Okay. very similar to that. So which one is true statement? The program is wrong, but how wrong it is, okay? Why it is wrong? Which one? Adeline, are you okay? Hello, Lin, are you okay?
Yeah, I'm still kind of thinking about this.
It will enter a list of positive integer. That's the hint. Positive integer. And what happened to this guy? This guy is a 0, so you go through, always process a 0. That's not my positive integer. Is that okay?
Yeah.
So the answer is the code will always process value not on the list. D. Okay? Does that make sense? You say that you are going to process all positive integer, but in fact, there's a 0 will sneak in. Is that okay? There will be a 0 that will sneak in. How to solve the problem? You can only move your value. You should duplicate your read outside the for loop one more time. You read a new value before you enter into the loop. That's actually okay. Does that make sense? You duplicate this last line one more time over here. That would be okay. I think it's okay.
Oh yeah.
Okay, number 17. Okay, 17, we have such a call. So this one again, you have a X, Y, okay, and then trying to see what's the outcome of X, Y. Okay, this one is like that, okay. So this one, let me see, number 18, Natasha, right? So what is the answer for this one? So this one, you need to trace the loop, right? Are you okay?
Yeah, I'm still thinking.
You may need to have a table for this one. Okay, let's actually work together. This one probably you cannot just look at it. Okay, you have to pull out your pencil and paper, trying to do it. Okay, so initial value you have the X and Y. X is actually equals 10, Y equals 0. You get started from here, so you have X greater than 5, Y will be assigned with 3. Okay, while Y less than X, you go into here. Okay, Y less than X, yes. So X times equals 6 equals 2, you get to 6. Okay, if Y actually divided by X equals 1, which is not, you actually will go back to the while loop. Okay, Y less than X, you'll be double, so you get the 12. Okay, you get 12, and then will Y divided by X equals 1 now prime together? No, I don't. Actually, let me see. Y and X prime together? No, that's wrong, right? That's wrong. So you go back to here, and your Y less than X. No, this one is wrong. This one is wrong. So you go out. You go out, and then X decrease by 3. So X at this moment, X will go to what? Let's continue on the next row. Okay. So here your Y will be 12, and then next one your X becomes 7. If X becomes 7, you decrease by 3. So You decrease by 3, and you will actually finish this one. Either this one, you x greater than 5, yes, greater than 5, and then your y was set to 3. So you go to 3, and then go to 6, go to 12. Is repeating this whole thing one more time. And then after that, you have a 12, and then x drop down to 4 because it decreased by 4, 3. So you end up with this, you actually go up to here, then your x greater than 5 is wrong. So you terminate your program over here. Okay, so the answer is D. So this one, without drawing such diagram, you will not be able to get an answer. Okay? This type of problem, we call it what? Scoreboarding way, okay? You must use a scoreboard. You do not have scoreboard, you are not able to solve this problem. Is that okay? Hello?
Yeah.
Okay, remember it, okay? So this one answer is D, okay? I'm trying to teach you different way of doing it. I give you a try, but it's okay, right or wrong, not a series, okay? So we try to give you a way to do it. Okay, this one is a little bit long. Let me actually shrinking it, okay? So number 18 and 19, based on this problem, okay, based on this. Let me actually make it a little bit smaller, okay? 18 and 19 based on this statement. So next one, Oscar, okay, working on this one. So
Okay.
this one is a program that invoke the checksum, okay? So you will calculate the checksum, okay, you call it, and then, okay, the answer is that which will result in a valid checksum that will return true, okay? So the whole thing is that here are some number, which one will cause it to be true, okay? So let me write down the number on the right side, okay? Then you don't need to scroll down. We don't need to scroll down the image. So A would be 6143, B would be 6144, C would be 6145, D would be 6146, E would be 6147. Okay, that's actually really different numbers. So go up to here. Okay, which one will return true?
We'll read it.
Okay, take your time. Okay. So you got a number, okay, and check digit is actually getting the check digit. So check digit, I believe the check digit should be the last digit. So this last digit is check digit, okay? And then remaining will divide by 10, okay? So you take 3, so actually D2, D2, D1, D3, these are D2, D1, D3, okay? So this whole thing is sum modular by 7 is your IEM. So check your IEM, the sum 10 modular by 7, if it is equal to the checksum, that's it, okay? So you have 614 plus together you have 11, take modular by 7, you get 4. Is that okay? Is that okay?
Yeah. Yeah.
Okay. This one a little bit complicated, so I solve it for you. Okay, no problem. Number 19, okay, go to William, okay. Number 19, what number 19 is? What is okay, this one is associated with this problem. What is the purpose of the remaining number? What is the purpose for that? So basically, this one is similar to my program here, okay? The success division, right? I've been talking about success division. Okay, I told you that's very important, right? It is actually every time you continues to divide, so that remaining actually is the earn every time we use, okay? That's the earn every time we use. So what's the purpose of that earn? So that's used for this purpose, right? Getting the integer into digit, right? Into digit successive division. Is that okay? So 1, 2, 3, 4. You take multiply by this, you get 4. Next time you have 1, 2, 3, get 1 digit. 1, 2, get 1 digit. 1, get 1 digit. Is that okay? Does that make sense? Hello, hi William. Does that make sense? Okay, we have to move on. Okay, number 20. Go back to Amy. Okay, number 20. So what output will be produced by this code segment? Okay, so you don't need to check it. Just try to come out with the printing you have. Okay, Amy, is that okay?
Yeah.
Yeah, try. So apparently it changes line whenever 5 go down to 1. Okay. So basically when your I equals 5, 4, 3, 2, 1. So every time you change line, change line, change line. Okay. So it's okay. Now this portion will tell you what will be printed over here. Okay.
The first row is 97531, and then 7531.
So it's B, right?
Yeah, B.
It's B. Okay, number 21. 21, go to demo, okay? Demo when number 21 is a 1, 2, 3 problem. So 1, 2, 3 problem, you need to check who will be printing something like this. So let me pull up a little bit. Make it a little bit smaller, okay? So this one, which one will print out this way, okay? So you say A true on A yes or no, 1 yes or no, 2 yes or no, 3 yes or no. This 1, 2, 3 type of problem usually is like that. You check and then you go down to check whether which one is the answer, okay? So they are trying to print 2 dash 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 4 dash 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 6, something like that. Okay? The patterns like that.
I think the first one does.
The first one does, yes. And then how about second one? Will you do it?
I'm still reading.
Yeah.
I think the second one also does.
Yeah, second one also, yes. How about the third one? Let me make it bigger now. Over this. Okay, I'm sorry. I'm lost. Actually, it's okay. It's actually over here. Okay, this is 21. Okay. The third one also is okay.
Yeah.
Okay, that take a while. Okay, but see here, this kind of problem is actually time consuming. Okay, so you are getting into such a problem. Okay, I don't suggest you to guess, but if you have time, you try to go through it. If you don't have time, you might need to budget your time. Okay, this one is a very time consuming because you go down to the answer only D or E. Okay, it's actually, well, This one actually, if you find out one is the answer, okay? If you find out one is the answer, you should not go check number 2. You should check number 3. You know what I'm saying? Hello?
Yeah.
To save time, you go down to, you know one is correct, right? So one is correct, you check number 3. It save more time, okay? Okay, anyway. Number 22, go down to Eric, let me see, no, Katie, okay? Katie, wait. Number 22.
Let me think.
This one is a little bit hard, okay? This one is a little bit hard. So as you can see, the algorithm is similar to my successive division, okay? Similar to the successive division.
I think one is false.
One is false. Yes, one is false. Okay, this one, you know one is false. Then you can only have B, C, D, right? So in that case, I will also suggest you check 3. You know what I'm saying?
Yeah.
Because it can only be B, C, D, okay? Okay, 3 is very simple. Less than 0, less than equals 10, less than equal 10, you basically bypass the while loop. So you print what? Right?
Yeah.
So 3 is correct. 3 is correct, so you have a CD left. Now how about 2?
I think 2 is correct.
There is no initial value for if there's no initial for num, for cause infinite loop for it or no? Actually, it's greater than 10. You will keep dividing, right? You keep dividing. Will there be number that actually is too big that it will infinite loop? No, it will never happen that way. So answer is D. Is that okay?
Yeah.
Every time it's divided by 10. So go several times. Several times it will drop down to below 10. Okay. No matter
I have a question.
Yes.
So what if never mind. I don't have a question.
Okay.
Sorry.
No problem. Okay. Okay, number 23. Let me see. Lin. Okay, go back to Lin. Okay, this one is still a big problem. So it's a reverse. See, now it comes to reverse. Okay. So which one will do reverse? Okay, which one will do reverse? Given there's the remainder and the reverse number. Remainder number is R, we will return. Remainder is you take the remainder, okay? So which one will give you the answer? So reverse, remember we have 1, 2, 3, 4. We are going to reverse to 3, 4, 3, 2, 1, right? So that I told you that you need to do this, right? It actually is a sign that this may be correct. Okay.
Sorry, would you mind scroll up a little bit?
Yes. The up only define 2 variables, remainder and remainder none. Okay. So basically, these 2 number is remainder. You have the 2, 3, 4. Okay. So you put this guy into remainder. Okay. And the result you want to return, the R I use actually is right now called reverse number. Is that okay?
Yeah.
Yeah, and which one would get the result? Okay. Let me pull up a little bit. Okay. So how about this one? This one and this one, how much difference it has? These two loops actually are identical. Is that okay?
Yeah.
So the answer is D. Is that okay? These two loops are equivalent. Okay. So you see, I go through different algorithm. Please try to, after class, if you really don't understand it, try to redo it by yourself. Okay. You see that this kind of the successive division, okay, it happened on the problem several times. I do not collect those programs out of fun, okay? It's really useful. Whatever I show you today, the algorithm I show you today, they are all very useful algorithms, okay? Any question? No question will be end here, okay? Thank you for joining us, okay? Then see you next Saturday, okay? Any question?
Thank you.
No question? Okay, bye-bye now. Bye-bye.
Oh wait, I have a question.
Yes, go ahead.
Wait, I just want to clarify. Wait, what is the format for the homework submission for the MCQ?
MCQ, you just give me the answer, A, B, C, D, E.
Those spaces, right?
Space, okay, but I suggest you to every line put 10 answer and space like in the middle. Is that okay?
Okay, okay.
It's easier for us to read, but if you give me A, B, C, D, E, or the whole one in one string, that will still work. But normally we don't know which one you get wrong. Is that okay?
Okay.
Also, you don't know how many questions you have already answered. So that's very risky. So it's better that you just provide A, B, C, D, E, C, D, E, E, A, okay. And then number 11, you go to here. So we know that it's number 1, number 5, number 6, number 10, okay?
Okay.
You just put into one string, I think that will still work, okay?
Okay.
Any more question? How about Doris? Do you have any suggestion? Doris, do you have any suggestion? Okay, no suggestion, no question. We end here, okay? Thank you. See you next week, okay? Bye-bye.
Thank you.
Thank you.
Bye-bye.